Hey, so we're going to look at checking if a viewport or if viewports overlap on a sheet. Um, we're going to use Dynamo to do this. And so I have a few slides here talking about why would you overlap views, and then we'll talk about actually finding the sheets with overlapping views or viewports. Viewports are technically what they are, but here I'm referring to them as views. Viewports are just views looking at the views. So, with this said, I'm gonna show some examples of ways that you may overlap views. I would love to hear your use cases and how you do it. I have personally never really needed to overlap views, or have seen many people do that, but it is something you can do in Revit, and this script can be a way that you can use it. You can use it to QC these views, and plus I think it was a fun exercise just to try to build it, and so we'll get into that script, and I'll show you kind of what that looks like. So anyways, why would you overlap views? To compare or coordinate different aspects of the design, to show more details in a single view, to compare design options. This view down here, this is a view from the mechanical or the MEP advanced sample model, and I think it's either E101 or E301. We'll actually look at this model in a little bit, but on that sheet they have these two views, and you can see the levels have been dragged over to the right. So and then it's just a single view, and so I thought that was kind of interesting and a cool way to show this information, but those are overlapping views, and so that's one of those use cases. So finding the sheets that are that have overlapping viewports. The way I was thinking was, I want to identify which ones are overlapping. That's pretty easy because you can get the viewports bounding box, kind of the location of where that viewport is. And then from there, you can try to determine if they're overlapping. And so, and really, that's pretty straightforward because all you have to do is does it intersect? Because there's an intersect function or method in Dynamo that allows you to look at two bounding boxes and see if they intersect. And so by using that method, you can easily figure out if two are intersecting with each other. And so another one of the things, I was thinking about you could potentially use this for is for QCing a model. And it's like, well, maybe I want to not necessarily grab all the instances. Maybe I want to grab specific, like a percentage of overlap. So as an example, we have like these two squares here. And so it's like, well, if I'm going to be doing this, I'm going to have two views that are going to be 100% overlapped. So they're going to be right on top of each other. And so a way that we could potentially QC this in an effective way that it isn't just going to report a bunch of information that we have to then go through is to try to find the ones that are, let's say, above 96%. So they're 96% overlap, but they do not, but they're not 100%. And so we can report 96% overlap, and that may indicate to us that whenever somebody placed these two views on top of each other, they didn't put it exactly on top. Anyways, that's one way. Another thing was interesting is like, what if you have two viewports, all right, and you've got one, and you want to figure out that percentage. maybe there's some reason why you want to do that. But I thought that was an interesting problem, because then what you're essentially doing is trying to figure out the percentage of the smallest one, the smallest viewport, overlapping the larger one. So you get the intersection, and then you get the overlap. All right, so you get the area of the overlap, and then you compare it to the smallest viewport, and that gives you the percentage of the overlap of the viewport. So, and that's kind of what I drew what I was trying to show here. And I do find, and this is a side note, but sometimes sketching things out is really helpful. And I tried to do this as an example here. It's not pretty, but it doesn't have to be. But it's a good way to work through problems and try to understand them before you get into Dynamo. Over here, it's to the right. Because we're working with bounding boxes, we get the midpoint and the max point. And it's actually pretty easy to calculate the area, because from there, we just need this corner point, because then that'll give us the length and the height of this or the width and the length of the bounding box, and then we can calculate the area of the viewport, and then compare the two, and then figure out like the percentage of overlap. So that's what I was trying to show here. And so you can get the X of the max point and the Y of the midpoint, and then that can help you determine what this point is, and then from there you just get the distances from each of those points. Pretty easy. And if you don't know what I'm talking about, when you're working with a bounding box, you can get the midpoint and max point. If you haven't worked with bounding boxes before, I would say Google it and look into it and try to mess around with the nodes. But essentially, we're just grabbing the area around an object. In this case, it's viewports. They could be three-dimensional, and in this case, we just need the X and Y. We don't need the Z because we're working with sheets. So this is the script. It's actually really straightforward. For the most part, it's pretty simple. The more complicated part is in these scripts here. So I've got actually the original Python script that I wrote to try to solve this problem. And then I have the refactored by ChatGPT Python script. So I'll talk about that because I think that's really important. And then refactored by ChatGPT and further developed because I added some more functionality that return the area which you see here. So, and actually I have another slide here that shows you what the output is. So in this example model, we've got 3 sheets. 2 of the sheets have no overlapping viewports. 1 of the sheets do. And the viewport is a 99.9% overlap. So that may indicate us that there's just a little bit of like one of the viewports is off from the other one, just a tiny bit. Probably doesn't even matter. But yeah, so you won't see anything in this list, this other list. But after you filter, because you can use this false true list to filter your sheets, return your sheets, and then this list here is your matched list to your sheet list. And so now you can see like 1-to-1. Okay, this is the overlap of viewports, and then here's the sheet that's for. Some resources. So Revit op-ed has a post, and it's like, it's not much. It just says, hey, it's something you can do, pretty much. And it's from 2005, so a pretty old one. But just wanted to share that. And then there's Real World Revit, overlapping plans, and then view overlapping on sheet and Revit. This is a YouTube video. This is by Ben. He's Revit Study channel. And this channel is actually active still. Oops. Because this post, I think, is from 6 years ago. But this actually might be a cool, if you're interested in Revit and learning more stuff about Revit, it might be a cool channel to follow. But you can see here, they have this elevation of of all of the buildings, and then they have a floor plan up here. So I thought that was kind of cool and a cool way to show that. So that could be another way of overlapping views. I think this this video it shows you that how he's placing this, but it shows you there's also an order to how these things are stacked, and it's dependent on when you drag it into a view. So keep that in mind, and that's kind of what he's showing in this video. So anyways, check that out if you're interested. Also, be sure to join the Discord. The link's here. It's also in the description below. So check that out if you want to join the community and talk with other folks that are into BIM and design technology. I think it's pretty close to 700 people on the server. This is an old image. I need to update this, but we have a lot of different channels and a lot of people that are a part of this community. So I think it's really cool. I like it. I post questions in there sometimes or things that I have trouble with, and then a lot of other folks do as well. So check that out if you want to. So anyways, let's jump into it. So I've got a model here, and I tried to create like a really basic example of overlapping viewports, like something maybe you would do, but we have two different viewports that have two different design options. One of them I have the floor hidden in it, but you can see they're overlapping, and we've got, you know, the furniture that this here is representing like option A, and then this one's option B. And so what we can do, and I've got the Dynamo script open, is if we run this, let's look at this one here. We'll see that there's one view that's overlapping. And then I've actually got a filter by bool mass that's going to return the sheet, and then we can get the sheet number. We can see it's A4. Scroll down, see that this is A4, that's the active sheet, so we can see it's this sheet here. And then we can see it's actually 99% overlap. See if I can try to pull this all on one screen. Alright, so now if I shift this over a little bit, run this again, you'll see that it's a 78% overlap. And, you know, from there we can, you know, visit that sheet and fix it and say, okay, well, it's 78%. That's not right, so let me either pull them away from each other, or if, in this case, if they do need to overlap, let's go ahead and get those in the right spot. Run it again. 99. I'm not so sure why I'm getting that. I would say that's pretty darn close and not a big deal. But you can get 100. There's another example I'll show you, but it shouldn't be a problem overlapping. There might be some other reason why I'm having trouble getting that to be perfectly right. It could be rounding it wrong or something. But anyways, so real quick to talk about this script before we look at the Python bit of it. So we're getting the sheets, all right. Then we're just getting all the elements of that category. So we've got 3 sheets in this case. Then we're going to get the viewports. Those are different than views. Views are not the same as viewports. Viewports are just like a lens into a view. So, and those are separate. If you tried to get the view itself and then read the location of it, it would be in the context of Revit and the view by itself. It wouldn't be in the context of a sheet, which a viewport location would be, and which is what we're trying to go after. We're trying to understand where does the viewport sit within the sheet so we can determine if they overlap. And then viewport box outline. And so that will return the bounding box. And then from there, that's when we run it through Python to do the other stuff. I originally built this actually to work in Dynamo, or just only in Dynamo, but I wasn't thinking when I built it, because initially I actually grabbed a single bounding box or a single viewport and I checked it against every other viewport, and if it didn't clash with any of those, then it would read out as false, nothing, no viewports overlap. But essentially that caused a problem, because if you had like the second viewport, well, what if the second one clashed against the third viewport? Well, you wouldn't catch that. So instead of having a bunch of cross-lacing and a bunch of Dynamo scripts to catch all those instances, it was easier just to build it in Python. And so initially that's what I did. And so I built it here, and all it's doing is it's looping through. So it loops through, and my input, as you saw, is a list, and then each list is a sheet, and then these are the viewports for that sheet. So that you can see this list 1 has a bunch of viewports on it. And so what we're going to do is a loop through that first, and so that's going to return our boxes. All right, so then we're going to check if the boxes are greater than 1, because if it's 1, or if there's no viewport, then that would read out as false. There's nothing should clash because there's only one viewport. And then what we do is you go for I is the index, and then box, in boxes, enumerate is so that we can pull the index value while we're looping through it. And then we do the same thing, J is the index, and then we do the other box. We make sure that the indexes aren't the same, so essentially that we're not clashing against viewport 1 against viewport 1, because that would mean that all sheets would have a clash, which is not, or an intersection, which is not good. So we just make sure those aren't hitting each other. And then we say and bounding box intersect. So if both of those are true, and this is index, this is I, not equal to J. So by the way, that's what that is, not equal. Bool's not append, true. Else append false. And this is not an optimized way of looping through this. And I was working through it and trying to think of different ways to make it better. One way is to actively pop stuff out, because if we check index 1 for this viewport, then it's going to check against all of these and say, okay, this bounding box clashes with none of these. Well, we don't need to keep that in our list no more. So let's go ahead and pop it. And then when we move to this object, it's just checking if this bounding box clashes with these other bounding boxes. And it doesn't do this one because we popped it from the list. So that makes it more optimized. And then a second thing I did was, if it's true, let's just break the list, the loop. I mean, sure, there might be other viewports that overlap each other, but that person's going to have to check that sheet anyway. So let's just break the loop and move forward from there. So anyways, those are the two things I could think of to optimize this a little bit better. And so from there, that's when I was like, oh, wait, like ChatGPT would be a really good thing to try. And so I was like, all right, here's my code. Here's what I've written so far. Can you optimize this? And I would like it to do these couple things. And you can see I've written those things up here. So pop items from lists while you're looping through them, and then stop loop when true. So it got this right off the bat. I had to rephrase it and do some other, like a couple times to get it to add this part to it. And so you can see 4 boxes in viewport, bounding boxes, and we've got a lot of the same stuff. And then we've got this variable that we didn't have before that just by default says false, and it says, and then we've got this loop here, and then we've got this same if statement, and then it says, all right, because of these conditions are true, we're going to change this to true. All right, and then we're going to break this loop right here. All right, and then it's going to come down here and check if intersects is true, and if it is, it's going to break this loop right here. and then else pop it from the list, and then, restart or continue looping through until you find either true or you get through the whole list and none of the bounding boxes intersect with anything. And there's probably even a better way to do this. Like, you don't need to loop through the last elements or whatever. I don't know. But that pop reduces the list while we're looping through it. Now, I haven't had any issues with this, but I know modifying lists while you loop through it can cause issues. But because it's at the end here and it restarts the for loop up here, I want to say it shouldn't be a problem, especially since we're using the index values and stuff. But it works, and it seems to be faster than it was before. So, and I'm not a perfect programmer. I'm still learning, but I've had issues when modifying a list while you're iterating through it. But because we're iterating through it and, starting over and not, popping it and try to do something else, I think it's fine. So, and then after that, I do out.append intersects, which is going to be either false or true. Or yes, that's it. So it'll either be false or true. And then from there, we will this else is for this if statement up here. So if this is not true, then it's going to append false, because it's saying, hey, there's no way you're going to have any overlapping viewports when there's none or just one viewport on the sheet. So we're just going to go ahead and add false to that. So anyways, that's the script. And I did have to add so it got me probably a good way there. And then I had to tweak a couple things. Like, I had to put a break here so that it would end the loop if this was true. And then I had to change something else. I can't remember. But as you could imagine, I knew what I needed to do. I knew I needed to write it. And so I just asked it to do what I wanted. And you could see how potentially I saved 30 minutes or an hour. And I just copied it in, tweaked a couple things, and it was good to go. So if you're good at asking, I think a skill that is needed for that is knowing code so you know what you need to do, but then also knowing how to phrase the questions properly so that it outputs you what you need out of ChatGPT. So incredible tool. Totally recommend you checking it out if you haven't already. So anyways, there's that. I'm going to close this. And this is so this is the same thing, but I wanted to, for fun, and we talked a bit about this when we were looking at the PowerPoint. But it's like, if maybe there's a way for me to determine what the percentage of overlap is, so that I only focus on ones that are overlapped by a certain percentage. So this one's 99%. Let's say if it was 96%, that might be an issue. So again, say somebody accidentally didn't line that up properly. Well, that's a QC issue. We want to make sure that looks right before we print anything. So over here to the right, I've got another check, and it says if any of these are greater than 96, and I could actually do something like greater than 96 and less than 100, but for now I just have this. So if it's greater than 96, go ahead and return that. You can see it's returning sheet A4, which is this one. It tells us, hey, we need to look at this because that is too close to be used for something else, essentially. Because you may have like a 50-50 overlap or something else in a way that it's overlapping. That might be that might not be something you need to check. But for these ones, you're like, what they're probably trying to do is have them like right on top of each other, which this means that it's 4% off. So let's go ahead and take a look at that. So I thought that was a fun thing to build and to see if it, I thought it was an interesting thing that potentially could be a practical use case. I don't use that for projects, but if that's something that you guys have trouble on in the past, then you could see where potentially that could be helpful. All right, so here's the other one. So ChatGPT and Further Developed. I had fun with this because I had to build a couple functions. You can see it's a little bit more complicated, and that's because I had to calculate the overlap. And that's where that image I showed in the presentation or the PowerPoint, why I was trying to figure that out. It's like, okay, if you've got two viewports that are not the same, how do you determine what the overlap or the percentage is? And that's taking the intersection bounding box. And the intersection bounding box is the bounding box of the overlap of the two different viewports. Take that, compare it to the smallest viewport, and that's what will tell you the percentage of overlap when you have two different sized viewports. And so I've got two functions here. This one's for the distance. So this just calcs two different points. And I have point 1, point 2. I think there is a function within Revit or within Dynamo to check 2 points, but I'm actually passing in two tuples of the XY, and then I'm just doing Pythagorean's theorem and just trying to figure out the distance between those numbers. And that returns us the distances, which in that presentation, it's that corner point to the max point, and then again the corner point to the midpoint. So this point here, I'm calculating this one to this, and then calculating over here to this point. And then we can take those two distances and then just figure out the area for that bounding box, which then we can use to figure out the percentage of overlap. So this is the other function, get bounding box area. And so we've got two things. We have the new input, and this is just going to take the bounding box max point, the X and the Y. And that's just going to return a number. And then this is a tuple that I've got here. All right, and then we've got the max point. Or sorry, I didn't say this right. New point, this gets the corner point. So this here. And what we've got is bounding box dot max point, the X. So I'm going to open this one more time. So we've got the max point, the X, and the midpoint Y determines this point here. And so we've got the bounding box max point X, the bounding box midpoint XY. That's our new point. And then these are our other points. We're just getting the XYs for each of them. Same with this midpoint. And then we're just going to calc the area, which is the distance of new point to max point, and then times the distance of new point and midpoint distance. And that gives us the area. And then we can use that function later to determine what two areas, how much they overlap. So a lot of this stuff is the same. We looked at this already. This is the part that I added. So get overlap percentage. And so we've got the bounding box overlap. And so this is the overlap, because this function right here, bounding box dot intersection or method, returns like another bounding box. But in this case, it's the bounding box of the overlap between the two different bounding boxes. So that's kind of confusing. And let me see. So, you've got this bounding box, and then you've got this bounding box. What that method does is it returns this right here, this square right there, and then that's your intersection essentially. So how the intersection of the two bounding boxes, and it returns that. So that's what this is. Total overlap area. So we use the area for the bounding box, or we use that function to get the area for this here, because we're going to use this and compare it later on. All right, and then what we're going to do is we're going to, and real quick, I'm going to mention, so this is the total overlap of that intersection bounding box. That's the area. All right, we want to check it against the smallest viewport. Now, each viewport could be the same size. In that case, it doesn't matter. But if a viewport is smaller, we want to check that viewport. So back in the PowerPoint, we would want to check this one against this. So these two here, check these, and that would give us the percentage of overlap, because we wouldn't do it the other way, because that wouldn't make sense. Because of course this would overlap that entirely. So we want to get the smallest. In this case, when these overlap, they're the same size. So it doesn't matter. It tells us exactly how they overlap each other. But in this case, when we have a smaller one, that's the one we're going to use to determine the percentage of how much they overlap each other. And so that's why I have this variable. So mid underscore bounding box equals box by default. And then essentially what we do is we just check to see if that's true. So we get bounding box area box, and then we do it for the other box, the other viewport. And then whatever's smaller, if this is true, if this box is greater than this other box, then it goes ahead and assigns other box to this mid variable. But if it's not, it just leaves it as is. Because essentially what we're trying to do, again, is grab the smallest viewport. Then I'll just calc the area. So I again run that function. So now we've got this one, and then we've got this up here. Or sorry, this one here. So we got total overlap area, and then mid bounding box area. And then we can calculate those together and figure out the percentage of overlap. So down here, just create a list called areas, and then I pass, or I say intersections.areas.append min areas, because it's taking, these are both numbers, and it's taking the minimum value, because we want the minimum value to be the first one. And so it takes the minimum bounding box area, and then it takes the total overlap area, it takes the max areas, and then it just times that to 100, and that gives us the percentage of overlap. So that gives us our total area percentage, and then again, this just stops the loop if it's true, and then I've got a note there saying the same thing, and then we've got this here, which we're popping this for optimization purposes, so as I mentioned before. And all right, so that's that. I'm gonna save that, close it, and then we'll look at the other model. So we've got our electrical, the MEP advanced sample project, and let me reopen Dynamo. So this one has a couple views that are overlapping each other, and so we will check those. And then also let's check this view too. So we'll grab the other lighting view. Place it right. So that should be 100, like 100% overlap. Now, if we run this, we will get the two sheets, or the three sheets. We'll get, and let's get this side by side so you can see. So, all right, so we're looking at sheet E201. We can see it's index 1. So we can look down here, index 1. It's 100% overlap. So we know, okay, they're probably checking multiple views. That's something we don't need to QC. But here's another one, 17. That's E301. So if we jump over to that sheet, we'll see what's going on. This one might be something that needs to be QC'd. It's got some weird overlap, and I don't know what's going on with this view. But you can see it's 17%. If I grab that, you can see how much it overlaps. I should be able to, if we run that again, should see 100. Yep. So you can see 100% overlap. That is different than the other overlap. So you could see where you could build in other things like, hey, do these views, are they the exact same size? And if that's the case, that's different. You know, that may be something we want to QC when it's two views that are exact same size that are reading out 97%, because that means that somebody didn't put it in the right spot. Or if it's two views that are not the same. So if we look actually at this 92%, and that's E101, let's jump over to that sheet. We'll see that these two sheets, or these two viewports, this one's slightly, so it's practically over it. It's 92% of that viewport is on this other viewport, but you can see it's hanging off a little bit. Well, 8%. These two viewports are not at all the same size, and so you can have another function that checks that, and then says, okay, if they're not the same size, there's probably some other logical reason to why these are overlapped that much. Or overlapped at all, so we can ignore those. Let's only look at the ones that are the same exact size, and then compare, and then only return those so that we can check those and QC them if they're not 100 but above 96% or something. I don't know. So, anyways, that's one. I mean, I find these exercises really interesting because you can take these principles and this application and apply it in various different ways. It doesn't have to be a QC process, but it could be something totally different, and that's why I think these are a lot of fun. There's so many other ways you can apply this same thing that we're doing here to another problem. And then here's that filter, so we can see that E101 is a problem. And like I said before, if you built in that functionality to ignore it, you could potentially remove these from that list so you're not wasting your time. But it depends on what your requirements are, how you set up sheets, or if there's some standard or logic to how you do things in your firm. So there's so many different ways you could set this up. You could ignore in this, it says riser diagrams here, so you could ignore certain types of views and only say do it for plan views or ceiling plans, and ignore it for other things. And so there's various ways for you to optimize it to get it to where it's returning the information that's valuable to you. In my opinion, it's I don't think more data is better. If I can get it to where it's giving the end user the information that's important to them, I think that's the best scenario. Clash detection is another good example. It's known for being overwhelming, but if you spend the time getting only what you need, and getting that to the right person at the right time, it makes the whole process more effective. So think about that stuff when you're developing anything. These nodes up here, I was going to talk about them, but because we talked about all this stuff here, it doesn't really matter, because essentially this is just a Dynamo version of getting the intersections between two viewports. But I'm just going to go ahead and delete that. Doesn't need to be there. And then I'm going to clean this up a little bit. And so there it is. That's the script. So not terribly complicated. Now, if you don't know Python, that probably is complicated. It was for me when I was new to Python. So that's something you don't need to know Python to do Dynamo, but totally recommend learning it. It's a lot of fun after you get over the hump. But this script, if you want to mess with it, you want to use it on your projects, or if you want to tweak it, do whatever you want, you can find it in my GitHub. Feel free to check that out and download it. Also, check out the Discord. The PowerPoint should be on my GitHub as well. Let me know if any of that information is missing. But anyways, thanks for watching, and I will see you in the next video.